All right, hello everybody. My name is Justin Richer, and I'm a security consultant based out of Boston. Today I'm going to be talking about not only security, but how we get around security on a day-to-day basis, because let's face it, this is something that we have all done from time to time. Everything that I'm going to be talking about today is based on a true story. These are things that really did happen. Some of them happened to me, some of them happened to people that I know, some of them happened that I just read about, but everything that I'm going to talk about is real, because it is a very real tension between security and functionality that we have in all of our systems every day. Because security is all about what you can't do, right? You're not allowed to make this action, or this person isn't allowed to do it, or you're not allowed to do it yet. But functionality is all about what you can do, what we expect you to be able to use the system for, what we expect you to be able to get done with things. And that causes friction between these two endpoints. Every single time they fight, that causes friction. And well, that's not to say that all friction is bad. Some friction is a good thing. This is why we put locks on doors. That's a bit of friction between walking through the door, right? But only if people have the right key to the door at the right time is that a reasonable amount of friction. Otherwise, it becomes an impediment. Because believe me, the wrong friction really gets people upset. And when people are upset and they're trying to do what they need to get done, they're going to find ways around it, because trust me, people are really, really good at figuring out how to get things unstuck in order to get their job done, right? And a lot of times people are going to do this using tools that they have just sitting around every day, the same tools that they need in order to do their job. Now, a lot of what I'm going to be talking about today really isn't in the terms of like malicious hacking, people coming in and trying to break in the system. These are people just trying to use the system in the way that they think that they need in order to get things done. Although this can lead to some more extreme examples of people getting around the security systems. But even then, these more extreme examples are often facilitated using tools sitting around, because this was obviously facilitated using that roll of duct tape in the background of the photo. The messaging that we give people for security and functionality is always at odds with each other for a whole bunch of different reasons. We tell people from the security side, just follow the rules, do what you're told, and everything's going to be just fine. But at the same time, we tell these same people, we want you to be clever, we want you to be innovative, we want you to take and solve hard problems and do interesting things with them, right? This, as you can imagine, creates things that are a little bit tricky, because if I don't follow the security advice, then I might get in trouble. Like if something breaks and if it's traced back to me and if people are upset enough about it, maybe I'll get in trouble for that. But if I don't get my job done, I am definitely getting in trouble. If I am not using the functionality that has been handed to me in order to get things done, I am absolutely going to be getting in trouble. So my motivations for this are very, very clear. And this is a lesson that most security engineers really don't want to see. The reason for this dichotomy, though, is that it is always easier to find a solution than it is to define a problem. It is always easier for somebody to find a solution to something that's bothering them, something that's getting in their way, something that is impeding them from doing what they think that they should be able to expect to do, than it is for a security engineer, a security team, an architect to define the problem that the security systems are trying to address. And that is always going to be the case. It is not a symmetrical playing field. So we're going to go into some real-life examples here, and we're going to talk first about passwords. This is something that I have talked about a couple of times here at Identiverse, also at the Cloud Identity World. So if you want more details on passwords, I've got old talks about that. Go ahead, dig those up. Now, fundamentally, password from the security mindset is it's something that you know. It is a factor of authentication. But in reality, a password is really just something that you can kind of look up or find or dig out of storage somewhere and use it when you need it. It's a shared secret, and the password itself doesn't care how that password is stored. And users are really, really good at coming up with ways to store passwords, aren't they? And this goes back to our security messaging, because we see things like this and we tell people, no, the password's supposed to be completely in your head. Never write it down, never come up with anything like that. But, instead maybe follow my, esoteric 12-step process for re-deriving the password that only you can remember. And that's going to be ridiculous. What we should really be saying is something from a functionality perspective, and that's use a secure password manager. A sticky note is a password manager just fine. It's just not a particularly secure one. We're attacking the wrong part of the problem. Now, we also tell people a lot, at least a lot of us are still telling people, that the complexity makes the password more difficult to guess. Research doesn't actually bear this out. That's why I've got the, I don't have a laser pointer, but that's why I've got the little asterisk on the side here. It doesn't actually bear this out, but what it does bear out is that more complexity makes that password difficult for people to remember and use, and the same with password rotation. Forcing people to change their passwords does not make it harder for attackers, but it does make it harder for legitimate users. And this is creating exactly that kind of friction that I was talking about. And in the right set of circumstances, you can get into a case of malicious compliance. This is when somebody looks at the rules of the system and says, I'm going to do exactly what you tell me to do, and it's not going to address any of the things that you're trying to get done here. So for this next example, I can't possibly tell you who it's about or what company that's from or anything like that. Couldn't possibly divulge those details. But there was a large security company that had an enterprising young security engineer, and they said, we're going to put increasingly arcane rules on all of the passwords on these systems in order to make things more secure. And that engineer looked at that and said, ooh, a challenge. This is going to be fun. Because the first set of rules that came across, as you guys know this one a lot, uppercase, lowercase, number, and symbol. And that engineer said, all right, you're making me throw out my perfectly good 40-character password that I can actually remember. Fine, my password is now password1, exclamation point. You happy? This follows every single rule that you told me, and it is an absolute garbage password that should not be allowed in any system whatsoever. It is a terrible password. But you know what? Follows all the security rules. Well, since we don't want that to be guessable or usable for more than 6 months at a time, we're going to make you rotate it. But it's a good thing you made me put a digit in my password, because now I can just increment that. Right? This is great, except that eventually the enterprising young security engineer decided to just flip back to password1 every now and again so that they wouldn't have to figure out which way this is. And then rules came down that said, well, now you can't use any of your last 24 passwords. We're going to keep those hashes around. And the engineer says, well, interestingly enough, turns out you can write a shell script that prompts for the current password, connects to the domain controller, cycles through 25 generated passwords, and then sets it back to the original input password. I have now followed every single rule that you have thrown at me, and I have kept my terrible password simply out of spite. Do not be mistaken. People are doing things like this. Absolutely are. And by the way, when strangely people said, you're not allowed to change your password that quickly, good thing we have sleep and cron job functions available, or else that'd be, awkward. Now, actual advice for everybody in the crowd is to use a password manager. Really use a good secure password manager. Don't memorize what you don't have to. Right? Let the computers do the job of memorizing it, and you protect access to that external memory store of shared secrets. Now, for things that you do have to type in a lot, and it's a good idea to remember, use a word list generator. Google correct horse battery staple for one of the more famous examples of why that actually makes sense. And this is my personal favorite advice of malicious compliance to all of you here today. If you run up to a system that says that you still need to use password characters, mixes, and stuff like that, go use a randomly generated password from a word list, and then append capital A, lowercase a, 1 exclamation point to the end of that password. This is malicious compliance, but it's also secure. It's just not secure by the thing that they're making you do. It's secure because of the thing that you knew how to do, and that's use a secure long password. All right, so let's get out of the world of passwords and talk about multi-factor authentication. In particular, we're going to talk about a hardware MFA token. This is something that you have. And in reality, this is something annoying that I have to carry around. I got to find it, and I'm probably going to lose it in a drawer someplace, but at least at the right time, hopefully I can get the output out of it. In particular, though, today, I want to talk about this guy. This is the RSA Secure ID one-time pad generator, and it's got a little character, 6-character display that puts up a 6-digit number every 30 seconds or so. These were ubiquitous a while ago. And honestly, from a security perspective, they're pretty good, but here's the thing. It turns out that this doesn't actually have to be something that you have. It just needs to be something that you can read the display of. And we have some interesting technology that allows you to see things when you're not sitting next to them and it's not in your pocket. That is a webcam for those that don't recognize it. And so now something that you have has been turned into something that you know, and that's the address of the feed of that webcam. And this is completely counter to what the security engineers tried to do with that token. But the thing is, you can get around all of these requirements without even needing to resort to using a webcam. I was at a government agency a number of years ago, and we were sitting out kind of in the public cafeteria space, and one of the people that we were working with had forgotten his secure ID back in his office and needed to get onto the VPN. So of course, he would walk like 3 buildings away to go get that and come back, right? No. He called up his office mate and said, hey, can you open up the top drawer of my desk and read out the 6 digits there? Thanks, type that in, I'm logged in and I'm good to go. Now something that I have is an office mate who can go look in my desk, right? And this is not what we have designed our systems for. The reason for this happening time and time again is that the context that we design our security in is not the context that people use their systems in. And we need to pay more attention to that difference, right? We need to iterate our systems with this in mind. So let's get out of initial logins and let's go into the federated space. I'm going to talk about a dead protocol, SAML, but OpenID Connect, you are not immune to these attacks. Now in a SAML system, you create a signed assertion, maybe even it's encrypted, you hand it to the user, that assertion goes across to the service. The service then checks the signature, checks all the crypto on that and says, hey, it's good, everything's good, so I can trust everything in that assertion, the person's logged in and we're good to go. Seems good, right? Well, especially with SAML, this process of checking things is really complicated. Who here has scars from XML DSIG implementations? Right, a few people. Eve's not putting her hand up, but I know the truth. All right, so these things fail. And the thing is, like, if any one of those checks fail, the entire assertion gets thrown out, which again makes sense from a security context because we want things to fail closed. But this suddenly makes a very bad day for an identity engineer, doesn't it? Because you're sitting there and stuff's not working, and then suddenly you get this call. Login is broken. I don't care what you're doing. I don't care what you have to do. I don't care what plugs you have to pull. Make it work right now. Okay, so as the identity engineer, I'm going to go look at the system, and I'm going to say, I've got a bunch of checks that are failing. I'm going to turn off those checks for now to figure out what's going on and figure out what's happening. But guess what happens? Well, suddenly, that perfectly good assertion that I know is good, or at least I believe is good, gets handed to the real user, and that gets handed to the legitimate service, and the user's logged in because I turned off all of those annoying security checks that were making it fail. So the positive case actually works, and guess what? You're now the hero. You made login work. Like, everybody thinks that this is amazing because all of the positive cases work until an attacker comes along and creates their own assertion with their own keys and just rolls in as whatever user that they want because you turned off all of the checks that were keeping them out. And you can't notice it because your system is working for all of the legitimate users. This is so common that we have actually enthroned this in one of our cards against identity cards, right? This happens a lot. And if you're interested in Cards Against Identity, come talk to me after. This is a real game that I helped design. I've got some decks here with me at Identiverse. Come talk to me afterwards. And anyway, so let's get away from users because users seem to be a big problem here. And let's talk about API keys and software provisioning. Because you got a legitimate developer. They have an application. We're going to make an API call to the API. And we're going to hand them some key that they can use that. Now, this can be a client secret. It can be an OAuth token directly, some static long-lived token. Or it can be a signing key. It can be any number of things like that. We spend a lot of time in our industry working about how to fix this bottom rung, right? We do a lot of really, really good work here. But we kind of brush this side of the system just under the rug. Figure people will deploy this. If they'll figure it out just fine. And a lot of people do get it right. There are secure systems to do that. But like the naive thing, though, is that we're still treating it as there's a person sitting there that has to go type something in order to make this thing start up and work. And I remember in the early VM days, there were systems that wouldn't boot up until you typed in the database password because it was insecure to store a database password. You would never want to do that. Well, we very quickly moved away from that and told people just shove it into your config files or into your code or something like that. And if you're storing that securely, that's all well and good until somebody decides to go check one of those files into the source control or put it on a publicly available web URL for your production system. I told you all of these are from real instances, and yes, those have happened. And in fact, the source control one is so common, you can go to GitHub today, and find people that realize that they've done this and are removing that from their code. One of the best things about this, though, is that you click on any one of these commits and you can go and see the secret in the previous commit. And it's a good thing nobody's trying to tell us to use an immutable blockchain in order to solve all of our security problems, right? Because that would just be dumb. Anybody who says that an immutable blockchain is the answer has never done a git force push. Anyway, let's talk about sessions. So sessions seem to be a great idea. We only want an authorized user, and we're going to have it time out when we need to. But if I am running, say, a science lab, and I've got a whole bunch of terminals around the building, I've got a bunch of people doing other things all day, and those computers need to be available when I need them available, right? I don't have time to have them go log in and take the gloves off and do whatever they did. They just need to be able to use that expensive equipment. So what I'm going to do as the manager of this lab is I'm going to take a map of my lab. I'm going to figure out where all of the terminals are and figure out a way to walk around that, and I'm going to go get me some slave labor to help me solve this problem. Because I can take that intern and tell them to follow that map and go press the control key on every single one of these terminals. This has the effect of resetting the session timeout, but not putting any inputs into the system, which means that I now have computers that are unlocked and available all day because they've been interacted with, but functionally, I am getting around the security systems that are in there. Right? Because once again, the place where it was designed is different from the place that it was used. One of my favorite examples of that dichotomy, though, is Google Glass. Who remembers Google Glass? It was a wearable computer, it lived on your face, and it had this really clever gesture-based authentication mechanism on the side, but it also had a bunch of sensors that it knew when it was on your face, and it knew when it had been taken off of your face. So once I put this on and I authenticate it, why on earth would it ever time out my session? Because it's still on my face. Who else is using this computer? It is literally on me. It is ridiculous to have a timeout on something like that when you've got that type of sensor. All right, I'm going to close with a personal story of conference registration. This actually happened to me just a few weeks ago over in Europe. I was speaking at a conference, and I show up to the registration booth and like, hi, I'm here, I'm speaking at the end of the week. I'd like to register. And they said, we have no idea who you are. Well, actually, what they said was, hey, Justin, it's good to see you. Because I'd spoken at these guys' conferences a number of times. They knew who I was, but the computer didn't know who I was. This is where things start to get interesting, because they said, you know what? Something must be weird with the computer because you're not in the system. We're pretty sure you're speaking. That part makes sense. So just go hang out in the conference for a couple hours while we get this figured out. So I got to go walk right past registration with 0 credentials and go into the conference, and it worked just fine. Now, because I legitimately was supposed to be registered here, I went back a couple hours later. We figured out some of the stuff that had gotten stuck and got it unstuck, and I ended up with 2 badges to that same conference, both of them printed from legitimate badge printers. Now, this isn't just 2 copies of the same badge. Those of you that want to scan those codes, these are 2 different registration codes for the same person, me, and they were both tied to me. Only one of them was actually valid, though, even though I got a totally legitimate badge for the invalid code. Interestingly, the invalid one is the one that actually doesn't have the printing mistakes, that doesn't have the smudged ink, right? Thankfully, I was able to go and give my talk about which featured Tom Holland and drag, and unfortunately, they rejected this talk here at Identiverse. So I know, right? Talk to the content chairs. Regardless, that was always a fun talk. The ultimate workaround, though, is to know a person, right? People are what get these systems unstuck, and people often know how to get these systems unstuck. And as we saw in one of the keynotes earlier today, that can sometimes be a terrifying thing. Because if I were to walk up to a conference registration system and say, hey, I'm supposed to be here, and I can sort of make that make sense, I can probably get away with a lot. It's amazing how many smaller venues you can get backstage by looking like you're with the band. Right? It happens all the time. And really my best advice here for people that are trying to get into things and get things done is walk around with all of the unearned confidence of a mediocre white man. It gets you really far in life. Like, you never know how far society is going to push you if you just act as if you're supposed to be there. It's amazing. All right. Now, to sum up. There will always be a workaround to all of our security systems, no matter how good we build them, because people need to use systems, and people are going to figure out ways around them. That shouldn't scare us, that should inspire us. because we need to know how to live with that fact. This friction is always going to be there. It needs to be the right kind of friction. We need to go around and talk to people and learn the workarounds that they're using today. And now a lot of security engineers are looking at this statement and saying like, oh yeah, I need to go and stop all of those workarounds right now, and I'm going to put in more controls and more friction to make them stop. That is the opposite of what you should be getting out of this talk, because what you should be doing is figuring out where the bad friction is. Make it so that people don't have to do the workarounds, because the people that I'm talking about are not trying to break your systems. They're just trying to get stuff done. And if you can make it so that people can get things done, they won't need to and won't want to do these workarounds. It is always easier to find a solution, though, than it is to define a problem. So we certainly have our work cut out for us. Thank you. And I've got a few minutes for questions. It was only 81 slides. It's fine. Eve. What's my position on security education? I think it's a good thing to have, but it's a bad thing to rely on. Peter Kesselman from Microsoft has this great talk where he says more and more of our systems are relying on a mythical breed of human called Homo securitas that makes all of the right security decisions. A brilliant way to frame the problem, especially in air-gap security protocols. I think it's good that people know, can recognize when they're being phished, that know like what the ceremony is supposed to look and feel like. But if our systems always rely on people making the right decisions, our systems will break in all of those spaces. So yeah, necessary, good, not sufficient. Yeah. Okay. Enablement versus enforcement? I don't know what you mean by that precisely. Could you restate that, please? Uh-huh. Oh, okay, so it's about enabling users to do the right thing. Yeah, I absolutely agree that, especially with developers, you really gotta make sure that they have the tools that they need, because otherwise they're going to write the tools that they need, like a shell script that connects to the domain controller to rotate their password, because that's literally what we are paying these developers to come up with, is clever things like that. And so pretending anything else is just going to get you into a world of hurt. That said, though, a lot of developers are not thinking about security as their primary thing, because they're thinking about what it is that they need to get done. And so giving them the right tools and the right guidance, this goes back to the education thing, to know that maybe you shouldn't be checking in your client credentials and your secret keys into Git, right? Give them escrow tools and KSMs and all this other stuff that they can actually use and use well, so that they don't have to come up with these other hacks and solutions just to make things work.
And there's a lot of work to be done there still.
Yes, so the comment was that there's a lot of work there to be done. There absolutely is. And this is, I'm seeing a lot of really interesting stuff that's happening out there in order to actually, make this, make this better for people and make this work. So one of the interesting things in sort of like the FIDO hardware authenticator space that I think is interesting is we're seeing a shift towards platform-based authenticators. Because this is something that is already on the system that is being authenticated. It is this is the device, the thing that I have. It's not something I have to add to the system that represents me. It's something that represents the device. And that is a really important shift in how we're thinking about something that you have, in terms of how we architect things, in terms of how we build things out. Yes? Yeah, so the question was whether it's better to use policy to define functionality or to use functionality to define your policy, basically. Yes, I agree philosophically, 100%. It's still really, really, really hard to do, because defining policy is here, right? Watching what people do on a day-to-day basis, figuring out what people need, is here. right? The friction that we create lives in this space even though we built it in this space. So I agree it should be, but ultimately it's going to be a feedback loop. In the most healthy systems, it's going to be a feedback loop where your new policies go and do something, you figure out what parts broke, and then you go refine that.
More of a commentary if this happens with you, being a little more open-minded as a security professional, how often did you find a problem within your own team of security professionals?
How often did I personally find it?
Because like you said, it was my approach. My team hated me. They were like, you're too outside of the box. You're supposed to be like this, this, and that. I'm like, it's not going to work. Everybody else is going to do their thing.
Oh, yeah. Yeah, so honestly, like more often than not, I am the problem within my own team that it's getting around things like that because I am a security expert and I'm an engineer and I'm just trying to get things done, so get out of my way. All right. You know, I told you some of these stories are allegedly personal. And so the thing is, it happens a lot. I think I have probably noticed it more because I have sort of trained myself to look for these kinds of things more than I think a lot of people working in the security space, especially the security architecture space, really look for. And I think that needs to change. And I think that this is something that can go into a different aspect of security education. Instead of educating people how to be secure, educating people how to build secure systems from end to end, from the ground up. Yeah. So it is, whether or not you know about it, it is happening everywhere, though. Absolutely guarantee it. All right. I think this is the last one, probably. Yes.
So you mentioned that you saw someone, at lunch at a conference who, got around the security key and things like that. How do you get out and talk to people to get the research to know the workarounds that are happening? What are your methods for like focus groups or however you're gathering all this data to try to define the problem?
So how do you gather the data to define the problem? Really, it can only, in my personal experience, it can only be gathered in situ. It's an ethnographic question. Like, because people are not going to sit in a focus group and tell you about all of the ways that they broke stuff. Unless you get a weirdo like me who's more than happy to sit down with the security team and tell you how I broke stuff because I think it's kind of cool. And then I get confused when I get in trouble. But really, it needs to be in situ. It needs to be people that are embedded in the systems. And this goes to another aspect that I think, thankfully, is changing in development team structure, is to having your security engineers and your security experts embedded in the teams the entire time, instead of thrown at a development team at the last minute saying, okay, now this is all the stuff we're going to tell you to turn off in order to make things work. Because if you have somebody that's focusing on the security of the project, they're also going to notice some of that infrastructure workarounds and sort of the weird processes and probably, hopefully, be able to have some improvements on those. Great question, though.
The guy that's break-in and the guy that's defending, both of those guys on the same team is just really a game changer.
So great point. What Ross said was that having the defender and the attacker on the same team is absolutely game-changing. And though you should always, it's going to be way too far back here. Where was it? Always be careful of your red teams, right? Because remember, they are on your team. So you got to make sure that you have a good relationship with them and not always just, willing to sweep things under the rug. All right, I think we're out of time. Thank you, everybody, very much.